Hi students, today the session is about the descriptive statistics. So the discussion is on the topics of statistics. So before going into the session, I would like to clarify one thing, the topics in descriptive statistics. Whatever we are going to consider here are all going to be the elementary level of statistics, and we'll try to give you some insights and make you interesting to know, to go to the depth and as much as possible under the given time frame. Hope I will do the justice for the with this presentation. So the idea is here, most of the topics you will see, the objective is to make you to comfortable with the statistics and understanding about the statistics, which will help you to use it in the R software for the computation analysis. So then you should be comfortable when you use these different tests. The first question is, so the objectives of statistical analysis. What is statistics? So now the basic fundamental question comes here is, what is really statistics? So if you want to say simply, statistics is a science of tuning data into information for decision making. So which tries to take out the information contained inside the data and converts it into a form which is useful for making what you say decision. It is not only the individual level, so it will help you to make decision at the individual level, office level, and even for the policy formulation and forecasting and prediction at the country level. Anything else is possible. So what we are going to do here is, we are trying to collect the data, analyze the data, based on that we will try to make some statistical inferences. Those inferences are drawn from the numerical facts, which we are going to call as a data. So data is very important here in statistics. So statistics is a collection, analysis and drawing of inferences from numerical facts, which we referred as a data. So data is a very important phenomena here in statistics. Then what is descriptive statistics? So this is the essential point, which is the starting point for knowledge discovery on the basis of data. So data is the very important source of information. So what if you see a raw data? So many will wonder, what data repeatedly telling about data, which we call it as very important source of information. Data cannot speak, it won't speak, data can't speak, and data cannot listen, data cannot understand our language. So then what is data? What data could do? Data has its own language, like sign language. Okay, so in descriptive statistics, which is the starting point for knowledge discovery and insights on the basis of data, data has its own language, like sign language. So what is that language? Statistics is a language of data. Statistics provides a scientific way to extract and retrieve the information hidden inside the data. As I said, no, to draw insights, to come up with new perspective, new view in the data. So the statistics provides a scientific way. So that is more important, the scientific way to extract and retrieve the information hidden inside the data. Statistics cannot do miracles. It can't do miracles, because it's a science, it's a scientific process, and it's a way. And statistic cannot change the process or phenomenon. Okay, as it involves many statistics, no, it won't change the process or the phenomena that you're going to measure or phenomenon that you're going to explain. It won't change. It's a process. So it's a process which gives you the what is the information, hidden views and hidden insights, hidden perspectives. So the statistical, then what the statistical tools does? Statistical tools provide forecasting, but not like astrologers parrots. As I said in the second point, it will provide forecasting by a scientific way. So it's a scientific way of analysis. For example, as I said, there are n number of statistical tools and n number of tests in any statistical package. If you use the correct statistical tool to the correct data, you will get a correct decision. You can take a correct decision. The wrong statistical tool for the correct data will definitely leads to an incorrect decision, and the correct statistical tool to the wrong data also leads you to the incorrect decision. So what is more important here is, for the correct data, the correct statistical tool has to be used. The choice of tools, okay, so a number of choice of tools are there in statistics. Okay, now let me start with the basic descriptive statistics. So in statistics, the several components and tools are there: graphical tools and analytical tools. So listed out here are all the graphical tools, various types of plots, two dimension and three dimension plots, scatter diagram, pie diagram, histogram, bar plot, box plot. So I would say this is only a myth. You simply have to choose the correct graph and you have to use the number of graphics. So appropriate graph has to be chosen. So use appropriate graphics to the appropriate data. I hope you all practiced with the scatter diagram, the list of graphical tools available listed out here in your previous exercises. So these are all in descriptive statistics. This graphical tool is one of the component where the data can be understood, where the data can be presented. Okay, and appropriate number of graphics is very important. Use the appropriate graphics, where to use pie diagram and where to use histogram, bar plot and box plot. Okay, so that analytical, that deciding using appropriate graphics is more important. And I am repeating, several components and tools in descriptive statistics in a very elementary level: graphical and analytical. In graphical tools, various types of plots, two-dimensional, three-dimensional plots, scatter diagram, pie diagram, histogram, bar plot and box plot. Next, going to the analytical tools, what are the different types of analytical tools and different aspects in which we try to analyze the data. For example, we try to find out the central tendency of data. So there are two things in analytical descriptive statistics. One is measures of central tendency and measures of dispersion. These are the two basic categories of analytical tools in descriptive statistics: measures of central tendency and measures of dispersion. So here, what is the list of the tools that comes in measures of central tendency are mean, median, mode, geometric mean, harmonic mean, quantiles, percentiles, etc. will falls under these measures of central tendency of data. So if you take the dispersion in data, we can calculate and we can able to find out the variance, standard deviation, standard error, mean deviation, absolute deviation, range. So how different we have used the tools mean, median. When we are trying to understand the variability in the data, we have different types of tools like the listed out in the dispersion in data. So there are different types of tools. So you can see here, in this case there are two aspects, as I said, central tendency and measures of dispersion. One, you have to choose in the list, you have to choose appropriate tool. And similarly, in case if you want to study the nature of variation in the data, so then you have to choose the appropriate tool. Similarly with the central tendency and dispersion. So as I said, use appropriate graphics in the graphical tools, and also in analytical tools, use the appropriate measurement, central tendency or measures of dispersion. And in addition to the analytical tools, there are two things to find out. If you want to visualize, or if you want to see the structure of the data or relationships in data, there are list of tools available. Symmetricity, that is symmetrics, to know the data symmetry, and skewness and kurtosis. These are all the this will help you to know the structure of data that you have in your hand, and the relationships in data: correlation coefficient, rank correlation, multiple correlation coefficient, partial correlation coefficient, correlation ratio, linear regression and nonlinear regression. So these are all also the analytical tools which are listed in the descriptive statistics to find out the relationship in data. So as I said in the previous slide, we can use the appropriate tool to find the measures of central tendency and measures of dispersion under these various techniques and tools. And to know the structure of data and relationship in data, different tools are available in statistics. You have to choose a proper tool. So if you have a data more than two aspects, something like height or weight, no, we can go for the relationship. Then in order to, it's up to you to select the right. So which of the tools to be used? Again the question, as I said, the graphical tools, listed out some graphical tools. These are all the graphical tools and analytical tools: central tendency, measures of dispersion, and data structure and the relationship. Which of the tools to be used? That is going to be the big question. Which of the tools to be used, graphical or analytical? So you can use both type of tools. You can use both types of tools, as I said, no, as your question or as your objective required. Okay, graphical tools provide a visualization of which will give you a first-hand information about your data. Analytical tools which give you the quantitative information. Both approaches work together and are inseparable elements. So you can use both types of tools. The issue is how you are going to, what you require. First hand information can be provided in terms of a visualization which provided by the graphical tools, and the quantitative information from the analytical tools. So from the beginning we are insisting, I am insisting the same thing: data is more important. Data is very important source of information. Okay, then why should then question there arise a question: why collect data? Why we should collect data? So data is collected to verify theoretical findings, so which will help you to draw inferences just on the basis of collected data. So which will help, so at the as a result we can develop statistical models which can be used for decisions, classification and forecasting in the later stage. So the data is collected to verify the theoretical findings which will come from the inferences just on the basis of the what the data which we collected, and in the later stage which will help you to develop a statistical model which is used for in future for decisions, classifications and forecastings. So here comes a new term: observations. So in data, in observations is through observations we can collect data. So as I said, to developing the statistical models, how to get data, this you all know how we can collect data. So we can collect data using laboratory experiments, through survey, primary data and secondary data. Okay, so these are all the source of data collection. So what are the different source where we can get data are all through laboratory experiments, through survey, through primary data and to secondary data. So you have to use the appropriate statistical tool according to the data that you are collected. As I am coming to the observations, which will help you to give you the outline of the structure. So the what is observation is, the observation is the units on which we measure the data are called observations. Okay, for example, number of persons. What you observe becomes the unit of measurement, units on which we measure the data, which is called observations. Number of persons, number of motorcycles, and your monthly income, monthly expenditure on gadgets. Okay, so these will give you, these are all the observations that we made. So these are the basic units on which we measure the data are called observations. So okay, where we are going to observe these things? The next question arises is where we can observe these things. Okay, So these things are all observed in the population. So population is known as the collection of all the units is called population. The units on which we measure the data are called observations. The collection of all the units is called population. For example, our objective is to find the average age of all the female students in class 10 in a school on basis of a sample. This is one, our objective is to find the average of all the female female students in the class 10 in a school on the basis of a sample. So the population here is all the female students in the class 10 in the school is the population. The sample is a subset of the population. So the selection of observations in the sample from the population is made in such a way that the sample is representative. So if your population is all the female students in class 10 in the school, you are going to select a samples. They are going to be where they are going to be observed. The selection of observations in the sample from the population is made. So that sample has to be representative of the population. So sample is representative. The sample should representate your population. What the representative sample means, all characteristics present in the population are also present in the samples. The characteristics of present in the population should present in the sample. So it's a representative sample. For example, to find how many female employees have salaries more than the respective male employees in a company on the basis of a sample. So all the male and female employees in the company will become your population. Sample is how a subset of the population. They have to be representative of the particular population. Okay, in some research, in some sampling frames, to define the sampling frame, if you take is more numbers, so okay, we can't survey the whole population. So there we will go for the samples. That is, as I said, the characteristics should be the same of the sample and population should be same. That is for the representative sample. How these samples has to be selected is the next question. There are various sampling schemes are there. How to collect simple random sampling. These are the sampling, different sampling techniques where you can collect the samples: stratified sampling, cluster sampling, systematic sampling, multi-phase sampling, multi-stage sampling. For example, as I said, the population of all the female students in the school is the population, but you are drawing some only 100 as your sample, just simply randomly asking them to stand on the line, and 11th first girl, 11th girl, 21st girl, 31st girl. So okay, like this is a simple random sampling. So if you are adapting a technique for stratification, okay, for example, if you are surveying for collecting data in a state, then you divide that state. You dividing the state according to the geographical or the political or as per the government zones. And so that is the stratification. So we will be having a backup and back support to stratify your geographical area and the population. Following the stratification unit is the stratified sampling, systematic sampling, and these samplings can be hybrid, and we can hybridized, and we can use systematic random sampling and multi-stage, multi-phase stratified sampling also can be used. So this sampling technique will help you to reduce the burden of instead of burden to collect the whole population data. So this what it will tell, the all characteristics the present in the population are also present in the sample. That has to be ensured. That's why it is a representative sample. So through this sampling technique, so what we are going to achieve is we are to collecting the data, because data is going to be the important, very important source for us to analyze. So with that data we can analyze and draw inferences to make a logical conclusion or decision making at the individual level, family level, organizational level, and to the even to the country level. So I am summarizing this today's presentation: descriptive statistics, graphical and analytical tools. Graphical tools listed out some tools like two-dimensional, three-dimensional plots, histogram, scatter diagram, pie diagram, bar plot, and box plot. And the analytical tools: measures of central tendency, measures of dispersion, central tendency, again mean, median, mode, mean, quantiles, percentiles, and measures of dispersion, variance, standard deviation, error, mean deviation, absolute deviation, and to know the structure of data and relationships. So these are all the items, these are all the tools that can be included to find out in the descriptive statistics. Only thing is what type of statistical tool that you are adopting, what type of statistical test that you are performing with your data matters. I have explained the sampling techniques to just how to collect the data that has to be representative data which will be applicable to the population, different sampling techniques. So it's very important to select the right appropriate tools and right appropriate statistical test to perform. And don't forget, remember, using the correct statistical tool for the using the correct statistical tool for the wrong data will lead to incorrect decision, and wrong statistical tool to the wrong data also will lead to incorrect decision. So the choice of tools is very important. Correct statistical to the correct data will definitely give you the correct decision to be generalized for the population. So this is the brief introduction about descriptive statistics, which will give you an idea at the elementary level. Okay, thank you. We'll see you in the next session.